Hello students, here is the first question of chemical bonding molecular structure. This question was asked in the JEE Main 2021 and the question is asked which of the following are isostructural? Means which of the molecule, which pair will have the same structure? To find a structure, what is very important for us to is to find a hybridization. We need to know what is hybridization. If hybridization is same, then structure will be same. For that, we require a electron pair count. We need to know what is electron pair count per molecule. Electron pair count. Like if it is four, if it is four, then it is sp3, and if it is sp3, then it is a tetrahedral structure. Right? If it is six, electron pair count is six, then it is hybridization could be like if it is six, then we can understand that the structure will be octahedral, right? So it depends. A structure will always depend upon the electron pair count, and here hybridization could be sp3 d2 or d2 sp3. These are the two possibilities, but whenever electron count is 6, electron pair count is 6, it is octahedral. This is when it is 4, it is tetrahedral. So let's find the electron pair count. Now, how electron pair count we need to find in a whole molecule? There is one basic simple formula you have to know, like electron pair count Z. Okay, Z is given to be is equal to Z2 is given to be is equal to half multiplied by V. I will define the terminologies Vm minus C plus A. Now Z represents the electron pair count. Z represents the electron pair count. Then what is V? V stands for the valence electron. This stands for valence electron. Okay. Then this represents a monovalent atom. Monovalent atom. What is the meaning of monovalent atom? Monovalent atom means, for example, if I take a hydrogen, if it is connected to central some metal atom, let's say central atom is this is A, and hydrogen is connected to that, then one single bond, the atom which is connected by one single bond is called monovalent atom. Like if I take a chlorine also, chlorine will be connected by this, and this will be stable. You don't require one more bond to complete its valency, right? To make it stable. Like if I consider, let's say this is central atom A and oxygen, like oxygen should be double bonded. This is not a monovalent atom, right? So this is a difference. This is a monovalent atom. Monovalent atom is where only one single covalent bond is formed, and divalent atom is where it could be a double bond or a triple or trivalent. Then it will be a triple bond. So that is the way. That is where we have to identify which one is how many monovalent atom is there. Okay, if there is no monovalent atom, let's say there is a metal, there is a central atom and oxygen is connected. Let's say one oxygen and five chlorine are connected. Then number of monovalent atom will be five. We won't be considering oxygen into that. So, okay, so this is the definition about the monovalent atom. C stands for cationic charge. C stands for the cationic charge, and A stands for the anionic charge. Anionic charge. Let's take a first pair. Let's take this pair, and among this, I will find for SO3. Let's find for SO4, Z for SO4 2 minus molecule, and I'm finding Z for this. So Z will be is equal to half the times central atom is sulfur, and we need to find the valence electron of the sulfur. We know the valence electron of the sulfur is 6. Valence electron of the sulfur is 6. Like carbon, sorry, oxygen, sulfur, they belong to the same group, and there the valence electron is 6. plus how many monovalent atom are connected. If you see over here, monovalent, it is oxygen. Oxygen is not a monovalent atom. It requires a double bond, right? Mostly it will be bonded by a double bond. So here, number of monovalent atom will be zero for that matter, because I will write it to be zero, because oxygen is not a monovalent atom. Like hydrogen, chlorine, or any halide are the monovalent atom. Minus charge, cationic charge. There is no cationic charge. It is a negative charge. So again, this is zero, plus anionic charge. What is the anionic charge? It is 2, right? Anionic charge is 2. So irrespective of the sign, here we will be writing that to be is equal to 2. So this will be over here, Z will be is equal to half the times 8, and over here I am getting Z is equal to 4. This is about the SO4. Means what hybridization is this? If Z is equal to 4, then the hybridization is sp3 and the structure is a tetrahedral. Right? Then CrO4 2 minus. Then there is a CrO4 2 minus. CrO4 2 minus. Chromium. When it comes to the chromium, it will have a 5 valence electron. So we will consider this to be a 5 valence electron. See the electronic configuration of the chromium. It is 4s1 3d5, right? So 5 valence electron plus number of monovalent atom. It is just oxygen, So mono, it is not a monovalent atom. So this is 0 minus 0, and anionic charge is 2, right? So this comes to, okay, half is there. 1 minute. Yeah, here outermost electron. Oh, okay, okay. I feel I have made a mistake over here. This is not 5. Valence electron for the chromium will be 6, right? 6 valence electron. Like how to find the valence electron of the chromium, right? It is, I can write it chromium. We can write, since atomic number for the chromium is 24, and electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d5. Like over here, we consider this 6 valence electron, because till here this completes the noble gas configuration, right? So this completes the electronic configuration of for the argon: 18 electron, 10, 12, and 16. So these are my valence electrons. Sorry, I made a mistake over here. It is 6, not 5. So again here the value of the z will be coming to be is equal to half the times 8, which will be is equal to 4. And here also the structure is hybridization is sp3 and both are sp3. So the option A is isostructural. Okay, in this case, A and B is given and A and C is given, right? So we know that. Let me check for the silicon chloride and Nh3 and NO3 minus, which are isostructural among this. So next pair, I'll take this question to the next page. So right now we are finding for a B silicon carbide, Z is equal to, like I'm finding for this. So Z is equal to given as a half the times valence electron plus number of monovalent atom minus charge on cation plus charge on anion, or we can say that cationic charge plus anionic charge. And I'm solving for silicon chloride and a titanium chloride, right? This belongs to the shell, sorry, this belongs to the group of the carbon, silicon, germanium, right? So silicon has how many valence electrons? Silicon has four valence electron. So I will write this to be 4 plus number of monovalent atom. The chlorine which is connected are monovalent. So it is 4 minus cationic charge is 0 and the anionic charge is again 0. Here also if you see the answer will come to 4. Z is equal to 4. So hybridization of the sp3 of the silicon chloride is sp3. Then next comes a titanium chloride. If I want to check for the titanium chloride, this was for the silicon chloride. This was for the silicon chloride. This is titanium chloride. Like scandium, titanium. Like it is a 22nd element, 22nd element titanium. And if you see electronic configuration for this could be written as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d2. Like till here it is argon, and here also it is. So we can consider this is to be a 4 valence electron for this. So half the times 4 valence electron plus number of monovalent atom is 4. There is no charge on this, 0 plus 0. And this hybridization is again answer will come to equal to 4. So here also hybridization is sp3. Okay, this is about the case where we found that A and B are isostructural. Okay, here does not end, question doesn't end, like we found it, option B is correct. But let's check what would be the hybridization for NH3 and NO3 also. Like this will make you understand how to find the hybridization when the different types of molecules are given in which there is no presence of the monovalent. And let's check for this. Um, so NH3 and NO3 minus, NH3 and NO3 minus. Let's check for this. NH3 and other is NO3 minus. So Z for this is half the times valence electron of the nitrogen is 5. Total number of the monovalent connected is 3. There is no charge. Cationic charge is also 0. This is also 0. Anionic charge is also 0, right? So this will be half the time. So over here Z will be is equal to 4. The hybridization is sp3. Over here Z will be is equal to half the times number of the valence electron is 5 plus monovalent. Oxygen is not a monovalent atom, so this is 0. Then anionic charge is 1. So I will write this to be, sorry, anionic charge is this is anion, first is anionic charge, right? So cationic charge. Let's write cationic. Cationic charge is 0 plus anionic charge is minus 1. Magnitude is 1. So I am writing that over here to be plus. So opposite we are writing. So this over here, this will be half the time 6. So here Z is equal to 3. Z means electron pair count. If Z is equal to 3, then the hybridization is sp2 and structure will be trigonal planar. Okay, so here this is tetrahedral and this is trigonal planar. In this case, we were getting that silicon chloride and both were having the sp3 hybridization. So both were having the structure to be a tetrahedral. Both were having the structure tetrahedral. In the this case also the structure was tetrahedral. So A and so these pair are isostructural, these pair are isostructural. Remaining BCl3 and BrCl3. Okay, let's check for BCl3 and BrCl3. BCl3 and BrCl3. For this, Z will be is equal to half the times valence electron for the boron is 3, right? Valence electron for the boron is 3 plus number of monovalent atom connected is 3. This is ionic and the cationic and the anionic charge are 0. So this over here Z will be is equal to 3. So the hybridization is sp2, right? Like the same way over here what we had done, sp2. So when it is 3, hybridization is sp2. So structure is a trigonal planar it is, and over here Z will be is equal to half the times bromine electron are 7, valence electron for the bromine is 7, plus this is this is what, number of monovalent atoms, that is 3, plus 0, sorry, minus 0 plus 0, because anionic and the cationic charges are 0. So this will be is equal to half the times 10, and this answer comes to Z will be is equal to 5. Here we are getting Z to be is equal to 5. So structure will be, if Z electron pair count to be is equal to Z, then it will be trigonal by this I am getting to be is equal to 5, then it will be trigonal by pyramidal. So here when it is 5, the hybridization is sp3d. You can remember this, right? So these are not isostructural. Okay, here is the next question. This question was asked in JEE Mains 2020. So question is about the structure again. If AB4 molecule is a polar molecule, what they have asked said is a AB4 molecule is a polar molecule. A possible geometry of the AB4 molecule. They're asking for the geometry. Geometry means it is it tells about the how the how mm, there is something called as a bond pair and the electron pair, right? So bond, how, what will be the orientation, how, what will be the arrangement of the bond pairs, right? So that is what is asked over here, right? What will be the arrangement of the bond pair? They did not give any information about the what will be the number of the lone pairs on a, right? We don't have this information. A possible geometry of a AB4 molecule is uh, means we can think of if it is a tetrahedral, just imagine if it is a tetrahedral and they said it is a polar molecule, means polar means what, there is a dipole for this. For example, if this is the molecule A is connected to this, and this is what the polar molecules are, like this is B, this is B, this is B, and this is B. Now let's say this is polar molecule and B is more electronegative than B, then this will be a delta negative and this is delta positive. In same case will be with others. So here the dipole moment will be oriented in this direction, and a tetrahedral angles, all the tetrahedral angles are equal. So all these dipole moments are going to get cancelled, right? And there will be no polarity left in the molecule, right? Um, AB4 molecule is a polar, means if it is a tetrahedral and if it is forming this structure tetrahedral, then there won't be polarity left in the molecule, right? If it is a square planar, if it is a square planar means structure is this way. Let's say this is A, this is A, this is B, this is B, this is B, and this is B. Like polarity will be this way, since B is more electronegative, that is what I have assumed. Again, here also there is a cancellation of the dipole moment. Here also there will be a cancellation of the dipole moment. This is square planar. Means we are assuming that geometry means there are no lone pairs. This will be the orientations, arrangement of all five atoms in one plane. And here, and this is non-polar molecules. So square planar is also not possible. Like even if it is a rectangular planar, it's not possible because all the atoms are same. Okay, rectangular planar is not possible because all atoms are same in that case. So even if we are saying that, let's say this is B atom, this is A atom, this is B, and this is B, and let's say this bond length is B and this bond length is B. Like this is something you will get to be like a rectangular. The drawing is not so perfect, but for this rectangular, we should have a different atom. This is also not possible. Square pyramidal. Square pyramidal means, let's say this is B atom. This will be this. Square pyramidal means, just imagine that it is at first stage. Let us assume that it is square planar. Square planar means what? This is B, this is A, this is A. There is no lone pair on this, right? And dipole moments are cancelling one another. But if there is a lone pair on this, if there is a lone pair on this, on A, there is a lone pair. Just imagine it this way. So it is going to push this down, and it will be like it is this way. This is square, and this will be like a triangle which will be forming, isn't it? So this is my B, this is my B, this is my B, this is my B, right? So this is the triangle, this is the square which is forming, and this is at the center of the square, and this is the lone pair. See, this will also have some dipole moment. Even if this is cancelling, then this will have, and net dipole moment won't be is equal to zero for this. So the option is a square pyramidal. The correct option for this is square pyramidal. Okay, here is the again one more question based on the dipole moment. Which of the following option contains a set of four molecules? Okay, each of the following options contains a set of four molecule. Identify the options or option. Okay, S represent option or options where all four molecule possesses a permanent dipole moment at room temperature. We want a molecule where all four molecule will possess a permanent dipole moment. This was a question of 2019 advance. Okay, means here more than one option may be correct, or sometimes only one option is correct. Okay, this is possible. So here we have to find the set where all four will have a permanent dipole moment. Like first example in the option A, if I take, it is Bf3. Bf3 means boron will have three valence electron. This is fluorine, this is fluorine, and this is fluorine. If you check the polarity of this, it will be oriented in this direction. All three dipoles are oriented in a exactly 120 degree to one another, right? And there is no lone pair also here. So here net dipole moment will be zero. Okay, one option is not there. One of the molecule from all four molecule is having zero dipole moment, where all four molecules will have permanent dipole moment. That is what is that. So option A, let's not check for others also. So here this is zero, means this is not a correct option. Then NO2. Let's check for the NO2, permanent dipole moment. Like, what is the criteria for the permanent dipole moment? Is that the dipole moment should not cancel one another. Like NO2 structure. NO2 structure is nitrogen will have a 5 valence electron. Nitrogen will have 5 valence electron, right? Since it is having the 5 valence electron uh, and just two atoms, there will be a one lone pair of electron on it, and it will have dipole moment, permanent dipole moment. If you check for the NH3 structure, okay, NO2 structure over here, okay, I'll tell you the structure. NO2 structure will be somewhat this way. So this is a coordinate covalent bond over here which will be forming, and this is plus one, right? So here if you see, the dipole moment are not going to get cancelled. Your dipole moment are not going to get cancelled. So it will have a dipole moment. If you check NH3 structure, if you see NH3 structure, then there will be a nitrogen this way, and this is hydrogens which are trigonal pyramidal manner, and this is the lone pair, right? So this will have higher dipole moment, and there won't be a overall cancellation of the dipole moment, right? So this will have a permanent dipole moment. POCl3. POCl3, how it looks is phosphorus is having a 5 valence electron. The structure will be this way. You can consider it this way, right? So here also there is no exact cancellation of the dipole. So this will also have a dipole moment. CHCl3. CHCl3 will have a tetrahedral structure. One will be Cl. This is H. This is H. This is H. Right? Here there is a polarity. Like here there is hardly any polarity. So here there is this is not polar bond, and there won't be any cancellation of the dipole moment. So this is the one which possesses a permanent dipole moment. So all four molecules will have a permanent dipole moment. Then sulfur dioxide. If you talk about the sulfur dioxide, then how the structure will be? Sulfur dioxide structure is this way, band structure. How? Because sulfur is having it belongs to the group 16, like oxygen family, and it will have six valence electron, and out of which two will be used for this, out of which four will be used for this, right? And four, and this is the five, six. This is the lone pair. This lone pair is going to push them down, and here also there is no cancellation of the dipole moment because magnitude of the dipole moment. um, for this will be maximum, and there won't be exact cancellation of the dipole moment. So here it will have a dipole moment, permanent dipole moment. C6H5Cl. Okay, C6H5Cl means this is benzene. This is benzene, and this is Cl, right? So there will be some polarity. There is no other dipole to cancel this. So this will also have the permanent dipole moment. H2 selenium. H2 selenium. So H2 selenium means again here selenium is group 16 element, means there will be two lone pair on this selenium, right? So four electrons are not involved in bonding and two electrons are involved in bonding. So this will have a different dipole moment. This will have a different, like this will have equivalent dipole moment, but here like there won't be a exact cancellation of the dipole moment because two are the lone pair and these are the bond pair. Even if it is having some dipole moment, then uh, we should show it this way. Hydrogen is more electropositive than selenium. So here also there is no cancellation of the dipole moment. So this is also showing a permanent dipole moment. Bromine F5. Bromine F5. Bromine is having a seven valence electron. Valence electron means out of seven valence electron, five will be used for bonding and one will be a lone pair in it. So again, this will there won't be a exact cancellation of the dipole moment, so this will have a permanent dipole moment. So option B and C are correct. Okay, let's check for the option beryllium chloride. What will happen to the beryllium chloride? See, beryllium chloride structure will be this. There won't be any lone pair on this beryllium. So here this is the beryllium chloride orientation, like it will have just two valence electron, hydrogen, helium, lithium, beryllium. Just two valence electron and both are involved in bonding. So here there is a exact cancellation. Carbon dioxide, if you see the structure, this is what the structure of the carbon dioxide. Exact cancellation of the dipole moment. So zero dipole moment for this, right? BCl3 also a planar trigonal planar structure because boron doesn't have any lone pair. Cl, Cl and Cl. So here also zero dipole moment. CHCl3 will have a dipole moment, but the question is all four sets, right? CHCl3 will have a dipole moment, but all four sets they are. So option B and C are correct for this question.